This is the HTC heating element, 24 volt, 60 watt, and temperature regulated at 230 degrees Celsius. There is the information for that one. They come in all different types. There are plastic covered heaters which can be used up against chicken troughs to keep the water from freezing. Here is what I'm going to do today. I'm just going to test this out by putting a plug on it. I'm going to test how long it takes to heat water to a certain amount. It's not going to boil, even though it's regulated to 230 degrees Celsius. It won't reach that temperature because I'm only going to use a cup of water in a big container. So I'm after a composite of what sort of temperatures will be reached. I first started off by just putting the plate on a little old breadboard, which I soon realised was going to burn like an iron, so it's quite hot. So I took that off and I actually ended up getting a brick, which is not going to burn. The whole purpose of this experiment is to see how these elements work in regards to the size of them. This one's only about 3 inches by an inch wide. It's very small. Could be inserted into a copper plate in regards to heating, for heating water. How many of them would you need? Don't know. Again, I'm just experimenting. The little plate heated up quite quickly, so I decided to take that temperature off and just put on this bowl. Well, you can see it's a fairly big bowl, even though it's got a small base. What's going to happen is that big bowl is going to be a bit like a heat sink, even though it says it'll get to 230 degrees Celsius. When you have a big bowl and a little water, what's going to happen is it will reach a temperature. Any physics students out there will know what I'm saying. It won't reach 230 degrees Celsius. It will reach probably 50, 60. Now, I started off room temperature, quite, well, it's not that hot today, warm, 30 degrees. And then I put the probe in. It had been on for about 2 or 3 minutes, so it was obviously already starting to heat up. It wasn't cheating, I'm telling you what I did. So the first readings were around 36, 37 I think, roughly. This says 35, but it got to about, there you go, it gets to 40 quite quickly. But I didn't put the probe directly over where the plate is, I put it to the side, so it's only measuring water temperature. You didn't want like a transfer of direct heat. But all I was after, to be honest with you, was getting that temperature up to about 40 degrees Celsius. I mean, I have a shower between 38 and 40 degrees. Some people, you know, that's about 100 degrees Fahrenheit. After 10 minutes, it got to 50 degrees Celsius, which is quite hot. If you had that temperature in say you're doing the dishes, it'd be warm. You know, you may add a bit of cold water to take the temperature down a bit. So all I did was, and this is showing you, this is the charge controller connected to the small bank. This was drawing 60 watts at 24 volts, and just because the surplus power during the day, wasn't using any. So after 15 minutes we got to 54 degrees Celsius. That's quite hot. You certainly wouldn't want to jump into a bath and put your bottom into that temperature. That would make you squeal. But 54 degrees centigrade. Now this is after 20 minutes. It got to just shy of 55 degrees, and then when it really boils down to it, this is probably about, you know, the end of the experiment. I thought, well, that's enough. It's about 40-45 minutes that I did. The temperature was very hot to touch, 56, 57 degrees Celsius. That's enough for me to say that how many of these would I need to heat up X amount of water to use for either loads of things, like keeping chicken troughs from freezing, heating water, maybe to have a shower. I'm going to do a few more experiments, but if you're interested, have a look at getting some yourself and doing a few experiments. If you have been, thank you for watching.